Hi, I'm Alex Jordan from Learn Color Grading and FilmSimplify.com, and Blackmagic Design just released their 6K pocket camera, which raises the question, what is a K? Because a lot of people are confused. You hear these terms being thrown around, like this is a 4K camera, a 2K camera, a 6K and 8K camera from Red. And then you have the TVs, the delivery medium. This is a 4K TV, this is a 1080p TV, an 8K TV at the moment. So the question is, what is a K? Okay, now just one disclaimer before we start. This is not a video to address the debate, because there's a debate whether you need 4K, you need 6K, do you need it, you don't need it. This is not addressing that. All what we're doing here is we're clarifying what does K stand for. So let's start. So to explain Ks, I'm going to be using my awesome drawing skills. I really don't know how to draw, so please just bear with me. This is going to be messy. So for example, okay, so supposedly this is the camera, there is a sensor in the camera, and then there's an image here of a man. So the image of the man gets through the lens and it just goes to the sensor, where the sensor analyzes the image. Now, if you take a look at the sensor has something called photocytes. It's just a fancy term for cells that are sensitive to light. That's all it is. This is the sensor. Okay, and it has certain number of photocytes. These photocytes are simply sensitive to light, and they just register, yes, at this point there is light here, at this point there is light here, and at this point there is light here. Now the sensor is dumb. All it does is it connects these points to recreate the image. That's all it does. So for example, if there was light here, it will connect the dot here. If there is a light here, it will connect the dot here to recreate the image we originally had. Every sensor has a different number of photocytes, and these photocytes really affect how the final image looks. For example, let's start with the first sensor. This sensor has a very low number of photocytes. For example, if I want to get the picture of this man through the lens, his image is overlaid on top of the sensor, and the sensor now will analyze the points where there is light, or it will just try to understand the image at these points here. This is an oversimplification, but just think of it this way. So in the case of this image, there will be a point here, then a point here, there will be maybe a point here, a point here. So these are the points, I guess, we have with this image, with this very low resolution sensor. So now when the computer wants to recreate this image, all it does, it just links the dots. So there is this dot here, there's information here, 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 and it just keeps on working like that. And when we remove the original image of the man, this is supposed to be the man? Yeah. You see the problem with low resolution sensors. You need a higher quality sensors with more dots to get a good image of the man. So to get a better image, we need to use a better sensor. So this sensor has more dots. So for example, if I want to recreate the image of the man, and just using the dots we have here, I'll just do like this, this. And now if I remove the image, notice this looks slightly more like the man we originally had. So because we had more dots, we were able to sample the image in a better way. So we had more sample points, which led to an image that looks slightly more like this man. Again, let's move to a higher quality sensor with more dots. So now let's take a look at the result. And we're actually starting to resemble the man in a better way. So let's move to an even higher resolution sensor. And now, if we take a look at this image that was taken with a higher quality sensor, notice what happened. We're starting to resemble the man even better. So in very simple terms, more sample dots on your sensor, or more points on the sensor that can capture information, will lead to something that resembles the original man better than another sensor with lower number of dots. Just take a look at this next to this. Here we had less dots to sample, so we ended up with this weird thing that should resemble the man somehow. However, here to the right, with more dots to sample, we managed to get a better image. Which gets us back to the question, what is a K? K simply refers to the number 1000. So 4K means 4000. That basically represents the number of dots that are horizontally on a TV, which means that, for example, of course this is portrait, but if it was landscape, it means that each and every line of dots have 4000 dots, or something close to that, because 4K differs a bit from one format to another, but there's generally around 4000 dots per line. That's where you get these numbers. So a 4K sensor has horizontally, so if we look at the TV like this, horizontally the TV will have 4000 dots. However, from a marketing perspective, 4000 dots, no one would buy a TV that says 4000 dots. So 4000 becomes 4K and dots are removed, so this is a 4K TV, or this is an 8K sensor. For example, the new Blackmagic Cinema Camera sensor has 6,144 pixels in every line. Remember, this means 6,000 pixels horizontally. So this makes it a 6K sensor. So K simply means 1000. That's all it does. And at the same time, the camera has 3,456. So 3,456 dots vertically. So that's cameras. Cameras record in this format, and you end up with a file that have all these dots baked into the file. However, we also have TVs. TVs also come in 4K, 6K, 8K, whatever. Again, this refers to the number of pixels. A pixel, again, the same way as a camera sensor is basically a collection of photo sites. In a simple form, a TV is a collection of pixels. So every TV has pixels, and the TV needs to redraw the image. So again, even if you record a lot of pixels, so we recorded however many pixels we have, if the TV has less pixels, it's going to reproduce a lower resolution image. And if the TV has more pixels, it will produce a better image. And if it has more pixels, it will even produce a better image that resembles real life in a better way. So that's simply a K. There is one more thing we need to discuss here, which is pixel density. Now, let's take a look at this sample for a TV. Now, this TV has 64 pixels. I have 8 lines. Every line contains 8 dots. So I have 1, 2, 3, 4, 5, 6, 7, 8 dots, and I have 8 lines of these dots. So this TV has 64 pixels. Let's compare this to another TV that also has 64 pixels. I'm going to remove this TV and introduce this TV. Well, this TV, even though that it has the same number of pixels, so 1, 2, 3, 4, 5, 6, 8, and we have 8 pixels, 8 lines of pixels here, this is a much smaller TV. Then let's compare this TV to an even smaller TV. This TV also contains 8 pixels per line, and we have 8 pixels. So the 3 TVs contain exactly the same number of pixels, which is 64 pixels. However, the pixel density is different from one TV to another because the pixels are more compact in one TV than the other. For example, I have this box here, and let's count the number of pixels that you can fit inside this box in every TV. So, for example, I'll just bring the first TV and overlay the box here. So we have 9 dots inside this box, or 9 pixels. So this is not a high density TV. So we don't have a lot of pixels inside the box. So let's remove this TV for now and overlay another TV on top of it. Notice something very important here. Even though the other TV contains the same number of pixels, so again, it's 64 pixels for this TV, we managed to squeeze more pixels. So there are higher density of pixels inside the box. I'm not gonna count them, but just trust me, there's more than 9 here. So let's remove this TV and finally bring the smallest TV, and it's very high density pixel count. So inside the box, we have a lot of pixels. Now, this is measured in PPI, or pixels per inch, which simply refers to how many pixels are squeezed into 1 inch on this TV. And this is where you see the number of ppi, especially on laptop screens. It refers to the density of pixels inside 1 inch. What does that mean? This box here represents your eye resolve factor. It means that a smaller TV will appear higher quality, even if it has the same number of pixels at like a larger TV. So for example, this large TV will appear not as sharp as a smaller TV, because the smaller TV, your eyes sees the pixels very close to each other, so it looks very sharp to your eye, even though this TV and this TV both have 64 pixels exactly. So when it comes to TVs, it's not simply the number of pixels that matters. What matters is the size of the TV, and even a large TV. If you have a very large TV and you stand very far from the TV in your field of view will end up looking like this, no matter how big the original TV is. That's why a lot of people cannot tell the difference when it comes to TVs between a 4K and a 1080p maybe from 2 meters away. So I hope that was easy to understand, and I hope you like this. If you like this, I'm sure you're going to like our DaVinci Resolve crash course, which is designed for the absolute beginner with no prior experience at all. The crash course is designed to take you through all the tabs of Resolve, all what Resolve does, and you'll be able to use the software once you're done. It's simply the easiest way to get you started with DaVinci Resolve for the absolute beginner. So please visit us at filmsimplified.com. Thank you.
Filmsimplified.com.